Moving on to meaning of behaviors. So one of the things we all know is the understanding and the science on brain and behaviors is so fast evolving. We know more and more and more of how this is. So obviously, I have the advantage of having picked up on the information and the knowledge in the last 5 years. And in order to understand, and this is one of the conversations we have all the time, is in order to understand abnormal, one must understand normal. What are the normative parameters of any given thing? I'll give you an example. If someone comes to me, you came to me and I gave you an MMSC and you scored 24, God forbid, your medical records will thereafter be riddled with a dementia. But we do not have any normal data. We haven't gone out there and said, let's bring 500 normal people between the ages of 50 and 55, 55 and 60, 60 and 65, and give them MMSE to see what is the standardized curve. Because I can tell you, if anybody's going to examine me 20 years from now, I have a hard time remembering words and names. So if you gave me on an MMSE those words that start with F, I will not be able to do it. I cannot do it today. I cannot do it then. So we don't have normatives. And that's very, very integral to understanding what we do. So basically, the next little bit, we're going to talk about the normal part of brain and behavior. And then we'll go to abnormal, because unless you understand normal, it is difficult to comprehend abnormal. Here is an approach that I have simplified as much as I can, and certainly using terminology that is reasonably self-explanatory. Our bodies are, you can break it down into 3 big systems. You have body circuits. We all know our bodies carry information to the brain. And then you have brain circuits. And brain circuits are the ones which assimilate all the information from the body to make sense of it. And then after the brain circuits have put all of that information through processing and assimilation, it leads to formation of brain functions, which then allow you and I to function, quote unquote, normal. And what are the brain functions? Basically, these are 4 big areas. The first big area is the higher cortical intellectual functions. This is your cognitive testing functions. So when you do MMSCs and MOCAs, this is what you are evaluating, higher cortical intellectual functions. Then, of course, the second most important function our brain does is thinking functions. We're all human beings, and our biggest peril is we think too much. And then the third important function are the emotional functions, because when we think, obviously it leads to emotions being generated. So if I'm thinking about something that somebody did something to me, my emotions are going to be, I get cross, I get upset. If I'm thinking nice things, I feel warm in my emotions. And then once the emotional functions have been generated, then that energy from the emotional functions or emotions is then fueled into social behaviors. So these are the broad 4 areas of brain function. And we're starting to now talk about, to begin with, higher cortical intellectual functions. We're going to try to understand those. And We talked about the brain circuits. So the brain circuit that subserves higher cortical intellectual function are the information processing circuits. So the brain, as you know, is one of the most complex parts of our body. And it is riddled with, I think, gazillions of neurons, nerve cells, which form such integral circuits that, as I understand, even the biggest, most complex, comprehensive supercomputer does not have the complexity of what the brain does. It's amazing. And the more you delve into it, the less you understand why it happens. There is information processing cascade. There are information processing theories. And neuropsychologists, we recently have a neuropsychologist, Dr. Sue. She spent 8 years looking at these information processing circuits and information processing cascades. And that is why they do neuropsychological testing. So this is what it is. So the thing I want to point out to you is the different kinds of memories. But the important thing is the working memories, which are the short-term memories, are the ones which give rise to long-term memories. And it's only after the memories are formed does all that information get put into a part of the brain that's called the Associational Cortex. You know, we keep talking about the frontal lobes and stuff, and why frontal lobes are so important, because only parts of the frontal lobes are a part of that associational cortex. Anything happens there, you really have no idea what's happening. And it's the second last pit stop, associational cortex. And that is the single most important part of the brain where all the information goes in. And once it goes into it, then the next step is formation of higher cortical intellectual function. So what are these higher cortical intellectual functions? And you guys are very familiar with that terminology. Executive functions, visuospatial, memory, short-term and long-term, language functions, praxis, gnosis, which is, praxis is motor, doing things. Gnosis is recognition, auditory, visual, all kinds of recognition. And then insight and judgment. So when you do all your testing, when you go back to pieces, when you do the intellectual function, when you do these tests, the reason why we do MMSE and MOCA is because what we're trying to do is evaluate different aspects of higher cortical intellectual functions. What MMSE does not do for you, MOCA does for you. And MOCA does it in the form of executive functions, which MMSE does not. It doesn't address it. So you can have someone with a great MMSE score, yet have executive dysfunction and severe neurocognitive disorder. Other terminology for that are the frontal lobe dementias. Those are the banes of our existence. The number of conversations we have about, is this person, does they know what they're doing? Because they're so well preserved. They talk to you like I'm talking to you, but really it's a challenge. So it's this higher cortical intellectual functions which you are. And the other important thing is this is the first layer of brain function. This has to be intact for all the other brain functions to even begin to work. So this is the first layer, the first base. It's almost like the foundation of everything we do. Is you have to have preserved information processing circuits. Only then can you have formation of higher cortical functions. And if higher cortical functions are not preserved, then all the other brain functions we've talked about will be impaired. So that's the key thing you must remember. Now we go on to the next part of the brain function, which is the thinking function. Going back to the other component, which is which brain circuits in the brain subserve thinking functions. And we have one of the most complex motivational circuits in our brain. Motivational circuits are the ones which are important for the higher cortical intellectual functions, which take information from internal and external environment of the body, and it leads to generation of thoughts. And I'm going to give you some examples of this a bit later as how this functions and for you guys to understand. But again, the key is you have to have preserved higher cortical functions for it to assimilate ongoing information, for you to have any thoughts of substance and meaning. So the next layer after the higher cortical intellectual functions is the layer of thinking functions, which is the motivational circuit. So you've got the information processing circuits, then you've got the motivational circuits. The third important function is the emotional function. And again, as we talked about it, the higher cortical intellectual functions have to be preserved. The motivational circuits have to be preserved. So thinking has to be preserved for you to then put that information into that associational cortex. It goes back into that black box where it leads to generation of emotions. And the generation and regulation of emotions are again controlled by very, very complex emotional regulatory circuits. So there are parts in the brain which actually regulate generation and regulation of any emotion that is formed. And the preservation of these circuits is integral for that. So this is the third layer in the brain function. The information processing circuits, the motivational circuits, and now on top of it, the emotional regulatory circuits. Once you've got your higher cortical functions, your thoughts, and your emotions all preserved, then all of that information again goes back into the associational cortex. And when it does, it leads to generation of social behavior. I refer to it as social adaptation and learning. It's a phenomenon we do every day. Social learning, social adaptation. But these are all parts of social behaviors. And these social behaviors are controlled and regulated by self-monitoring and regulatory circuits. And, one of the things you often find, we talk about in our individuals with persons with dementia, they've lost their ability to be self-aware of what they're doing. They've lost their ability to monitor what they're doing. They've lost their ability to track what they're doing and therefore lost their ability to regulate what they are doing. Because social behaviors are the highest version of human expression. And that is what gives us dignity, poise, and everything else, is we continuously regulate ourselves in a way that is appropriate. And so those are controlled and regulated by self-monitoring and regulatory circuits. And again, these circuits are all over the brain and they're all intertwined. But again, the important thing is you have now layers. It's like foundation, the base, high cortical, followed by thinking, followed by emotion, followed by behaviors. And this is where the beginnings of CBT came in as well, cognitive behavioral therapy. Thoughts, emotions, and behaviors. You take thoughts, which lead to generation of emotions. Emotions are the energy for behaviors. So how do you change behaviors? By changing thoughts. So the paradigm of CBT, so it all falls back to these common tenets of brain and behavior. In a pie chart, again, these are stacked on each other. I just didn't know how to do it. Information processing circuits are the key, followed by motivational circuits, followed by the emotional regulatory circuits, and then finally the self-regulatory or monitoring circuits. Let's overlap this again so that it represents each part to itself. So the information processing circuits are the ones responsible for higher cortical functions. Motivational circuits are responsible for thinking. Emotional regulatory circuits are responsible for generation and regulation of emotions. And self-regulatory circuits are responsible for modulating social behaviors. And so this is another way of coming back to where we started, which is the brain functions and the circuits which are in it. While we're at it, I might as well tell you what dementia is. Dementia is, when we say neurocognitive disorder, so this way we can understand what dementia is. It's a neurocognitive disorder which can have many, many etiologies, which is no different than you having pneumonia. You know, you can have pneumonia because of bacteria, you can have pneumonia because of viruses, and you can have pneumonia because of fungus, and you can have pneumonia because of chemical pneumonitis. You know, you drank something, it went the wrong way, or you aspirated. So pneumonia is pneumonia, but there are many causes, or what we call as etiologies. So dementia has many, many etiologies. So we have etiologies where, you know, again, when we talk about brain, we talk about proteins, we talk about water, we talk about electricity and chemicals. That's what brain and human body is all about. So protein synthesis is integral to brain structure and function. And there are many different proteins in the brain, many different protein cascades, pathways. And those protein pathways, amyloid is one protein, synucleotide is another protein, tau is another protein, and then tau is another protein. So these are the different proteins. So amyloid is where we talk about Alzheimer's disease, you know, amyloid hypotheses, because that particular protein is the one whose formation and destruction has been affected by the disease. And therefore, and what is one of the key chemicals or neurotransmitters in amyloid? Acetylcholine. And therefore came the beginnings of cognitive enhancers. So if there's any way we can prevent the formation of amyloid plaques, you know, where they form, they destroy the wrong way, and they get deposited in the brain. Obviously, when they get deposited in the brain, they cause an impairment in flow of information. So same with synucleopathy. This is the Parkinson's, the Parkinson's plus syndromes. All of those things are from here. And then tau and tau are the frontal lobe kind of executive dysfunction kind of dementias. Then there is the vascular etiology. You know, we talk about mini strokes and big strokes, segmental strokes, you know, that leads to. Then you have bleeds and leaks in the brain, that can lead to. You have head, you know, all that stuff. And then finally, you know, cardiac arrest, hypoxic damage, oxygen deprivation on a global anoxic way, all of that. And we see all these etiologies to a degree. And when they all come together, we call it mixed dementia. It's that saying that really after a certain stage, when you get to an MMSE of 15 or 16, beyond that, everything is mixed because every cascade has taken fold. I think in my, we had this one person at St. Peter's who was very complex, and the only family who actively wanted to get a brain autopsy done so that they would understand. And it was interesting to get those results. Everything that we are listing here was all in it. So really, by the end of the day, you know, it becomes splitting hairs, as far as I'm concerned, as to what type or what is the etiology, because just about everything. Yes, in the beginning stages, perhaps there is a pure version, but again, that is speculation hypothesis, simply because we're not doing brain biopsies and people who come into my clinic or geriatric medicine clinic to say, oh, okay, which hypothesis is this? So these are broad parameters. And then, of course, you've got trauma. So many, many etiologies. And so what happens? This is what happens. All these etiologies we've talked about, whether it's protein, whether it's vascular, whether it's traumatic, whether it is whatever, the place where they start to impact are on the information processing pathways or the information processing circuits. And when they start to impact on the information processing circuits, the first manifestation of that is impact on higher cortical functions. And when you have impact on higher cortical functions, that's where the MMSE and the MoCA goes. And that is the beginnings of dementia. But we've already established that these are layers. The most important layer in all of this are the information processing circuits. And when they start affected by cognitive or these etiologies, then it has to impact on the motivational circuits. It will then impact, so the information that is now going from those circuits into the association cortex to form thoughts is not going to be quote unquote normal, because now it's different. And when that information gets fed back into association cortex, your emotions are going to be different because it's no longer normal, whatever normal is. And then accordingly, you will have social behaviors which may not be within the normal spectrum. So this is the normal brain and behavior and how it gets affected by dementia. So park that for a bit, because that's just the one piece of the puzzle of brain and behavior. The second piece of this, which is very important to understand, is what I call as sensorium. It's a term that I was trained on, speaks to my age in some ways, but this term kind of fell out of literature, and I hope it can come back, because it is a very meaningful term, very meaningful construct. So sensorium has two components to it: your level of alertness or arousal, and then attention. Now, each has a very, very important function to subserve. The level of alertness or arousal is defined as the state of wakefulness in both your psychological and physiological domains. And why is it important? Because depending upon how alert you are, depending upon how awake you are, it determines your reaction time. And reaction time to the world and the stimulus and the triggers you live in. And the second thing it does is it's integral to processing speed on the information processing circuits. So it can be Sunday school driving, or it could be fast NASCAR pace. It's determined by your level of arousal. And these are very, very important pieces. And you guys deal with this every day. I'm just trying to put a face to it for you. Intuitively, you know it's all. I'm just saying, focus on this. And then attention. Attention is what chunk of information will be fed into or onto those information processing circuits. So as we go on through the day, people's wakefulness will diminish, their attentional abilities will diminish, which means their processing will slow down and there'll be less and less chunks of information going into being put on those circuits. So chances are, as we go through the day, your formation of those short-term memories and then into long-term memories will become diminished. Therefore, I will have this talk on my website. So it'll be on YouTube and website. So, simple principle, alertness or arousal with attention is sensorium. So here is the crux of what it is. We talked about the brain circuits and the brain functions, but the level that is even higher above in hierarchy, even before we talk about preservation or impaired brain circuits and therefore brain functions, is the role of sensorium. As I said, as we go through the day, as we go through waves of sleepiness, as we become less attentive, it impacts. And we know, how many examples can we give? And the other part, of course, is, I should go back. And the other part we should go is alertness is above attention. So even in that hierarchy, the higher is alertness, because the degree of mental arousal is the first thing. Because you can have changes in arousal, which will invariably impact changes in attention. But you can have preserved arousal and impaired attention. And it's important to know that difference. You don't have to be sleepy to be inattentive. You can be inattentive while you are awake because you're consumed with a problem at home and you're thinking. And when you're thinking, you're not attending. When you're not attending, your attention is off, which means that chunks of information that needs to go into your brain will be impaired. So the integral part here is alertness can be preserved and yet attention can be impaired. The other example I give to people is, cramming for exams. People drink all these Red Bulls and stuff and they're working 10 days in a row. They're very alert, but they're not attentive. They're gleeing through. They go to the exam and they can't remember a word. They were studying and everybody thought, my God, this guy's going to ace it. Turns out he bombs it because he was too distractible. So the amount of attention he was doing to bring bits of information in his brain was sketchy, was all over, was scattered because he was high on Red Bull. And so that's the part. Or you can give people, and that's one of the reasons why we say benzodiazepines, or for that matter, any medication, we give benzos bad rep, but why don't we gonna give people with cognitive impairment benzodiazepines? Because it makes them sleepy. Not the time when you want them, but the next day. So what happens then? They already have impairment. Now you've impaired the most integral part, which is the arousal. So if they were MMSE 7, now they're 0. And that's the important. So understand the arousal and the attention. And these are very, very important. So this is where then the brain, the model of brain is at the top is sensorium, then is preserved information processing circuits, next is preserved motivational circuits, next is emotional regulatory circuits, and then social regulatory circuits. And so this is the model of normal brain that I showed you. And these are the constructs that we need to understand when it comes to normal brain. regulation of sensorium, information processing circuits, motivational circuits, emotional regulatory circuits, and self-regulatory circuits. Because from here, then we move on to understanding the presence of behaviors in persons with dementia. So what are those? Because if you've got the normal, then you can extrapolate to what is abnormal based upon abnormalities in those domains.